Alright, Math 1 benchmark review. Now this one's a doozy, so it may be more than one. My suggestion, try to do as much as you can before you watch this video. Use this video to help you though, so you know what you're doing. And if there's more than one type of problem, watch the video, see how to do it, then try the other problem. So, if f of x equals 3x minus 5 and the domain of f is 2, 4, and 6, what is the range? So remember, domain is all the x values. So we take this 2, this 4, and this 6, we plug them into x, we simplify this, and that'll give us the range. So I'd go f of 2 first. 3 times 2 minus 5. 3 times 2 is 6, minus 5 is 1. So f of 2 equals 1. Then I do it for 4. So f of 4 equals 3 times 4 minus 5. That would give me 12 minus 5 gives me 7. So f of 4 equals 7. And then finally I do it for 6. So f of 6 equals 3 times 6 minus 5. 3 times 6 is 18 minus 5 would give us 13. So f of 6 equals 13. So my range is going to be 1, 7, and 13. Okay? So number 2. Now if f of x equals negative x plus 1 and the domain is 5, 25, and 50, we do the same thing for the range. Now that negative goes outside of it. Okay, so we get f of 5 equals negative 5 plus 1. So f of 5 would equal negative 4. And if we did it for f of 25, that would be a negative 25 plus 1, so negative 24. So f of 25, and then f of 50, you can probably guess this one, negative 50 plus 1, so negative 49. So our range is negative 4, negative 24, and negative 49. Now, had we dealt with a negative 5, it would have been a negative 5, so it would have ended up being a positive 5, just in case you see something like that. Alright. Now, number 3, given the graph of f of x below, what is f of 2? So this stands for our x value, that's our input. So I go to 2, then I go up to where my graph is. Okay, my graph is right here, so that's the point. And what's that point? It's 2, 7. So if my x is 2, what is my f of x? It's 7. So f of 2 equals 7. Okay, number 4, same idea. F of 6. So I go out to 6, go up to my graph. My y value is 8. So f of 6 equals 8. And that's all you had to do on those ones. It's alright if they're simple. Okay, now all these ones right here, 5, 6, 7, 8, 9, okay, they're all using that recursive equation notation. Remember, for the recursive equations, if we think about it, it's good to think about it like a table. It's connecting these outputs, okay? So if I know this, using recursion, I can figure out this, and I can figure out the next, and so on. Okay? So, the little subscript here tells me a sub n is just to find my next term. N represents what term it is. Okay, the first, second, third, fourth, and so on. Okay, a sub n minus 1 refers that if I want the fifth term, well, 5 minus 1 is 4, so I use the fourth term to find the fifth. Okay, so, but these are all outputs. Okay, so now it tells me a sub 3 equals 9. Let's do 5 first, actually. Erase this. So, a sub n equals a sub n minus 1, and a sub 5 equals 12. So, what I would do is go 5. A sub 5 is 12. I want to get to a sub 7. Okay, well, how's it growing? Well, what growth is, we're adding 4. So we add 4. 12 plus 4 would be 16. 16 plus 4 would give us, so if I really wanted to use the equation, I would go a sub 5 equals, actually 7, because that's what we want. equals a sub 7 minus 1 plus 4. Well, a sub 7 minus 1 is 6. Do we know what a sub 6 is? It's 16. So 16 plus 4 is 20. So our answer is 20. Alright, so number 6. So to me, the easiest way is to create a table. So I've got a sub 3. I'm trying to get to 5. So I need to know a sub 4. So a sub 3 is 9. What's my pattern of growth? We're adding 5. So this would be 14 plus 5 would give me 19. So a sub 5 equals 19. Okay, next one, a sub 2, and we're looking for a sub 4. So a sub 2 is 6. So our growth is timesing by 2. 6 times 2 is 12, times 2 is 24. So a sub 4 equals 24. Okay, number 8. These use b's, same idea. Okay, we've got b sub 3, which is 16. We're looking for 5, so we're timesing by 4. 16 times 4 is 64, I believe. 64 times 4 is 256, I want to say. Let's double check that. 16, 24, 25, yep. Okay, and the last one on this type, a sub 1 is 10. We want to find a sub 4, and our pattern of growth is adding 7. So we get 17 plus 7 is 24, plus 7 is 31. So a sub 4 equals 31. I don't think I wrote what b sub 5 is, 256. So with those ones, using the table of values is a great way to do that. Alright, jump into number 10. Now, rate of change. Okay, rate of change is usually the slope, except when we're dealing with these exponentials. Okay, exponentials are always going to give us an interval. These intervals stand for our x values. So I'm going to take this, find the x value for 8 by plugging it in, find the x value for 12 by plugging it in, then we're going to find what that slope is. So f of 8 equals 5 times 2 to the 8 over 4. 8 over 4 is 2, so 5 times 2 squared. 2 squared is 4, that's 2 times 2. 5 times 4 is 20. So f of 8 equals 20. So once again, kind of using a table can help us figure this out. So 8 for my input, my output was 20. Now I do it for 12. So f of 12 equals 5 times 2 to the 12 over 4. Well, 12 over 4 is 3, so 5 times 2 to the third. 2 to the third is 2 times 2 times 2, so that would be 4 times 2 is 8. 5 times 8 gives us 40. So f of 12 equals 40. Okay. Now we want to find our rate of change is the change in the y value over the x value, or the f of x value. Okay. So how does it change from 20 to 40? Well, we go up by 20. How does it change from 8 to 12? Well, we go up by 4. 20 divided by 4 gives us 5, so our rate of change is 5 from that interval 8 to 12. 5 what? I don't know, but 5 of something. Okay, so same idea for number 11. So interval of 4, so f of 4 equals 10 times 2 to the 4 over 2. 4 over 2 is 2. 2 squared is 4. 10 times 4 is 40. Okay, then f of 8 equals 10 times 2 to the 8 over 2. 8 over 2 is 4. 10 times 2 to the 4th. 2 times 2 is 4. Times 2 is 8. Times 2 is 16. So 10 times 16 gives us 160. So as we go from 4 to 8, our x value, that's plus 4. As we go from 40 to 160, that's 120. 120 divided by 4 would give us 30. Our rate of change is 30. Alright. Now, number 12. We want to graph an inequality. So we can use Desmos is a great tool. You would type them in, match up. I don't know what that's supposed to be. Something happened there, didn't it? Let me hurry and check something. Alright, so I looked it up. That should be 3x minus 4y is less than or equal to 16. Okay, that should be the fix. So you can go to Desmos on a calculator, graphing calculator, graph both those inequalities, and we're good to go. Okay, you can use your calculator to do the same thing. Okay, if not, there's a few different things we can do here. So for this first one, it's in standard form. I could turn it into slope-intercept by subtracting 3x, giving me negative 4y is less than or equal to 16 minus 3x, divide by negative 4. That would give me y is greater than or equal to, because times dividing by a negative switches the inequality, negative 4 plus 3/4 x. Okay, so it would be a solid line. Its y-intercept would be negative 4, so negative 4, negative 4, negative 4, negative 4. Solid line, solid. Okay, so all those work for that one. Slope of 3 over 4. So up 3 over 4. Up 3 over 4. Up 3 over 4. Up 3 over 4. So that's not going to help us. Okay, but that's how we'd graph that. Now, deciding which side to shade will help us. So if we pick our test point 0, 0, 0 for y, 0 for x, 0 is greater than or equal to negative 4 plus 0, because 3/4 times 0 is 0, which is negative 4. Is 0 greater than negative 4? Negative 4? That's true. So from this line, we should be shading above. So that one would work. This one wouldn't, so we can eliminate this answer. This one wouldn't, we can eliminate that one. This one would. Okay? So it's either A or D. The other way we could have graphed that one was using the x and y intercept. Make x 0, solve for y, find the y-intercept, make y 0, solve for x, find the x-intercept. That would be another way to do it. Okay? Same with number 12, you could do it that way. Okay? We could look at this and say, make 4 0, so that's 0. So 3y is less than 9, divide by 3, and we'd get y is less than 3. So our y-intercept would be 3, which that one's true, that one is also true. Okay, then we could do it for our x. So we'd get rid of the 3y, 4x is less than 9, divide by 4, we get y is less than 9 divided by 4 would be what? 2 1/4? 2.25, which that looks pretty close for our x-intercept, right? About 2.25. About 2.25, so that didn't help us. Okay, so looking at that, it's either A or D, right? So, now, that's not equal to, so it should be a dotted line, which is true here, not a dotted line. So let's double check to make sure it's shaded right. 0 for x. If we pick the test point 0, 0, 0 for y. 0 plus 0 is 0 less than 9. That's true, so they would have shaded down here. So yep, A is our true answer here. Okay? Alright. So 13, it says, given the equation in the table below, which of the following statements is true about the functions f of x and g of x? Okay, so it talks about the y-intercepts, and it talks about, that's it. So what are the y-intercepts? Well, slope-intercept form, y-intercept has x of 0, 2 over 5 times 0 leaves us with negative 3. So we have a negative 3 on this function f of x. G of x, okay, we go negative 4 to negative 2, so that's plus 2, then plus 4, then plus 2. Well, as we add 2, negative 29 to negative 17, we are adding 12, right? Negative 17 to 7. So negative 17 plus 24, because it would double to 7. 7 to 19 is plus 12. So if we expanded that out and went negative 4, negative 2, 0, 2, and 4, we'd be adding by 12, so we'd have negative 17 plus 12, which would give us negative 5. So g of x has a y-intercept of negative 5. So, is f of x less than g of x? No, because negative 5 is smaller, so not a. Can we find them? Yes. Okay. F of x is greater than y, than g of x. That's true. They are not equal, so definitely B. So we could find their x or y intercepts. Okay, 14. The function f of x represents the amount of air remaining in an exercise ball that originally has 4,500 cubic inches of air and is losing 6% of its air every minute. The function g of x equals 4,500 times 1 minus 0.03 to the x, doing the same thing. So the function, we're looking at rate of change, right? So first of all, can we determine the rate of change? Yes. Okay. Because we're given this interval 2, 5, we were given an equation or a story problem, we can figure it out. So it can't be that. Okay. So could they be equal? Maybe. So let's check it. So let's do the first one, the story problem. So we start out, our y-intercept is 4,500. Okay, we need to get to 2 and 5. So there's 2 and 5. So we need to find those. We're losing 6%. Well, if I take 4,500 and times it by 0.06, that means I lost 270 cubic inches that first time, which would be 4,230. Now I'd have to find 6% of that, times that by 0.06, and I would lose 253.8. Okay, so now this isn't the easiest way to do this. We've talked about these things, but I get 3976.2. Okay, so think of it this way. If we didn't lose any air, we would still have 100% of our air left. If we subtract 6% from that, that gives us 94%. So we're retaining 94%. So if I go 4,500 times 0.94, that gives me 4230. If I times that by 0.94, I get this one. So we're actually multiplying by 0.94. So the next one would be 3737.628. Then 3513.37032. Then for the fifth, 3,302.568101. Now, because the interval is from 2 to 5, those are the only two numbers I need. So this grows by adding 3, so 3 on the bottom. This grows by, so I take the 3,302.568101 minus 3,976.2. So that gives me a negative 673.631892. So negative 673 point all that stuff. Divide it by 3, and I get negative 224.544 if I round. Okay, there's my rate of change for this one. Now let's use the equation. So for the equation, since it has x, I just put 2 and 5 into my equation. So I go 4,500, 1 minus 0.03 squared, then do the same thing to the fifth. Okay, so essentially I'm just going 2 to 5. So we know that's plus 3. Okay, now if I do this one, I just type it into a calculator. It's the easiest thing to do. And we get 4,774.05. Then I do it for 5. Okay, and we get 5,216. Oh, hold on. I typed it in wrong. I forgot the minus. So that was actually, because that's getting bigger and that shouldn't be. We're losing there. So that should be 4234.05. Then if I do that one for 5, there we go, that looks better. We get 3864.303116. Now I take this one, subtract that one, giving me negative 369.74688844 divided by 3, and we get negative 123.249 if we round. So, are they the same? Nope. Did we find them? Yep. Is f of x greater or g of x? Well, red was g of x, purple was f of x. A smaller negative is actually greater, so it would be g of x. So the answer would be B. A lot of work for that, huh? Okay, 17. Or actually 15. Finish this slide, we'll be halfway done. Woohoo! Which explicit functions represent the pattern in the table below? Alright, so all we're doing explicit for linear, remember, is f of x equals our y-intercept, a, plus our slope, b, times x. Exponential is f of x equals our y-intercept, a, times our growth, b, to the x. So, let's see. How can we get from 5 to 35? Well, we could subtract 30. But if I subtracted 30, would it give me to negative 245? No. So how else can we do it? We could times by 7. So negative 5 times 7 is negative 35. Times by 7 again, it's negative 245. So we're timesing by 7. So now we can go like this. Because we're started with the first term, we can go f of x equals, we don't have our y-intercept. We have a sub 1. So if we have a sub 1, we subtract by 1 on our x. So I would go my first term, negative 5, times my growth, 7, to the x minus 1. Because then that would kick me back to the 0 term. Now, I could go ahead and find the 0 term by going backwards and realize it's negative 5 over 7 times 7 to the x. Okay, either one of those works. In exponential case, sometimes it's easier to do it this way. Okay. Now 16 gives us 0, so 32 to 21 we could subtract 11, subtract 11, subtract 11, so yeah, we're subtracting 11. So it is going to be linear. Okay, so we would go, our starting number 32, we'd go f of x equals 32 minus 11 times x, or negative 11x plus 32. Or we could also go from the 1 and go f of x equals 21 minus 11 times x minus 1. That one doesn't make as much sense to me, but you can do it that way as well. Okay, now 17, 18, 19, and 20, we are dealing with transforming those functions. Now, we've got two that we're multiplying, one that we're subtracting, one that we're adding. So to multiply, we take our two functions, f of x and g of x. So I go 5 to the x times 6. Now, does 6 have an x? No. So can we times 5 and 6? No. So what do? We just rewrite it as 6 times 5 to the x, and that's it. That's all we can do. Okay. 18, same idea. We're timesing 4 and 2 to the x, can't combine them. So for my new function, we'll call it h of x, it's going to be 4 times 2 to the x. That's all you can do. Now 19 and 20, we can do a little more. Okay, on 19, we're subtracting f of x. So I go 6x minus 7 minus the whole function negative x minus 3. So that negative applies to both, so I actually have 6x minus 7 plus x plus 3. Combine like terms, 6x and 1x gives us 7x. Negative 7 and 3 gives us a minus 4. And there's my new function. 19, we're adding them. So I just go 3x plus 2 plus 7x minus 1. Combine like terms, 3 and 7 give me 10x. 2 and 1, well, it's a minus 1, so 2 minus 1 gives me a plus 1. And there's all those ones. All right. Okay, now the same concept, only we're dealing with just the graphs. So 21 says we're given f of x, which is this line, g of x, which is this. What is the function rule for g of x in terms of f of x? So they want g of x equals f of x, and then however it's transformed. So remember, to do that, we look at their y-intercepts or their asymptotes. Either one would work. And we see from f of x, how far did we go down? Well, 1, 2, 3, 4, 5, 6. So what did we do? We subtracted 6 to it. And that's all we got there. For 22 down here, it says draw, given this graph, draw f of x plus 2. So plus 2 means we take every single point and we go up by 2. So the y-intercept would be at 1. This one would be up 2, at 3, up 2. Okay, so we'd have that parallel line looking something like that. Just added up twice. Okay, now we're kind of going back to some recursive and explicit stuff. So it says the recursive formula for an arithmetic sequence is given with a sub 1 equals 3. What is the seventh term? So we have a sub 1, which is 3. We want to get to the seventh term. So our pattern is adding 9, so we just keep adding 9. 3 plus 9 is 12, plus 9 is 21, then 30, then 39, then 48, and finally 57. So a sub 7 equals 57. Okay, 24 works the same exact way. We've got a sub 1 is 9. We want to find the first 4 terms. Oh, so we just want 1, 2, 3, and 4. So our pattern is adding 12. So 9 plus 12 would give us 21 plus 12, 33 plus 12, 45. And so our first 4 terms are 9, 21, 33, and 45. Okay, 25. The rule for a geometric sequence is this rule. That should just be a parentheses. What is the 8th term? So now we have a explicit term. So all we do is we put 8 in for n. So I go 64 times 1 over 8 to the 8 minus 1. Well, 8 minus 1 is 7. Okay, so 1/8 to the 7, so a calculator works great here. So I go 1 divided by 8 to the 7th. I take that number and I times it by 64. And we get a really small, well, not necessarily small, but yeah, pretty small. Okay, so 64 gives us about the fraction. If I did the fraction, it would be this. It would be 64 over 2097152. So as a decimal, it's 0.00030517578, and so on. Okay, very small because of that 1/8. 24 says what's the 5th term? So I go a sub 5 equals 3 times negative 2 to the 5 minus 1. 5 minus 1 we know is 4. So 3 times negative 2 to the 4th gives us 48. So a sub 5 equals 48. Easy enough, right? Alright, so this will be the first part. Let's see if we can get 29 and 28 done, but we'll pick up on this in another video. Okay, so you can find the second part. Alright, Leroy makes $9 per hour cleaning cars. His boss offers to pay him an additional $45 a week for cleaning the garage after work. What are the parameters? So we're looking at where did we start? What's our y-intercept? Okay, and how does it grow? What's our rate of change? For both 27 and 28. So where did we start? Well, if we clean the garage, that's only once, we'd start with $45, okay, a week. Then he cleans cars and he can make $9 per hour, so $9 per hour. Okay, 28, Jamal has a membership to a magazine club. He pays $5 per month for membership and $1.25 for each magazine. So is Y-intercept $5 per month. Rate of change is $1.25.